Okay, hi guys, we'll be continuing on saying Hund's rule of maximum multiplicity. So in the previous lecture, we wrote this statement that according to this rule, pinning of unpaired electrons in degenerate orbitals of a subshell will not take place until all the degenerate orbitals are singly filled and the spin must be parallel. So let's suppose we have px, py and pz. Okay, so what will happen first is, let's suppose the first electron comes, so it will be entering px. Okay, so after the entering of px, let's say another electron comes. So according to the Hund's rule, the second electron would be occupying the second degenerate orbital, which is py, rather than pairing up with the px, as it says that uh, all the degenerate orbitals would be unpaired until all are singly filled, and if the third electron also comes, it will be entering pz. Okay, now if the fourth electron comes, then obviously the and why we are not actually inserting the third electron in the anti-spin, because all the spin must be parallel. Hence for this electron also the spin would be parallel to the rest of the two electrons in px and py. Now when the fourth electron comes, pairing will start, fifth here, sixth here. Similarly, you can also have something like for the first three electrons, you can have the spin as something like this. This is also acceptable. Now let's talk about Aufbau's principle. Aufbau's principle states that filling of electrons in an orbital of a subshell takes place from a lower energy level to a higher energy level. Okay, and the energy level order is determined by the n plus n rule. So what is n plus l rule? N plus l rule is nothing but it is something like, first the electron will enter to that orbital for a subshell for which n plus l value is minimum. Okay, so let's say if we have 1s and 3p, then n plus l value for this is 1 plus 0, and n plus l value for this is n plus 3 plus 1. So n plus l value for this is 1 and for this is 4. So obviously 1s would be given higher priority as far as electron filling is concerned over 3p. Okay, this was just an example. I am just erasing it for the sake of clarity. So now, so in case of a tie between, let's say we have 2p and 3s, what is the n plus l here? 2 plus 1. And what is n plus l here? 3 plus 0. Final value is 3 here and final value is 3 here. So in case of a tie, the electron will first enter the orbital having lesser n value. Lesser n value here is 2p, so it will first enter 2p then 3s. Okay, so now let's draw the energy level diagram to write electronic configuration of atoms. Okay, so we have to determine the electronic configuration of atoms, and for that we need to determine in which order the electron would be filled. So this is according to the n plus l rule. So this is all the orbitals which have the same n plus l rule. N plus l rule for this would be 3 and 2p would be 3. This is 1, this is 2, this is 4, this is 5, and so on. I'm just not rewriting it again and again. I hope you can understand it. Okay, first 1s would be filled, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p, then 5s. Why? Obviously n plus l is same across the row, but n is minimum for 3d, hence it would be first entering 3d, then 4p, then 5s, then again 4d, 5p, 6s, then it would be entering, after 6s it would be entering 4f. Okay, 4f, then 5d, 6p, 6s, after 7s, 4f, 5d, 6p, 7s, after 7s it would be entering 5p. Similarly, you can have the arrows mentioned here. After 5s it would be entering 4d. Similarly, after 8s it would be entering 6f. Okay, so it would be entering 6f, then 7d. Okay, then it would be entering 8p, and then it would be entering 9s. So how would we write the representation or for the electronic configuration? So representation of electrons would be something like, or rather in configuration of element, it would be n lx, n would be shell L will be nothing but notation of subshell, and X will be electron present in subshell. Okay, so let's actually see some of the examples here. So we have first sodium 11. So it would have configuration like 1s2, 2s2, 2p6 and 3s1. Why? Because 11 electrons can be first 1s, 2s, then 2p, then 3s. So this order is followed for sodium as well. Then let us see for Mg12. For Mg12, first 1s2, how many are remaining? 10 electrons. 2s2, how many remaining? 8 electrons. 2p6, how many are remaining? 2 electrons. 3s2. Let us do for Ag47. So 1s2, so let us actually do something like this. So for n equals to 1, total number of electrons will be 2n square. N equals to 2, 8. N equals to 3, it would be 18. Total how much are already filled up to 3D? Up to 3D we would be having 28 are already been filled. Now let us take n equals to 4. Okay, so for n equals to 4 we would have again, it would be nothing but 18 plus till 18 all the 4s, 4p and 4d are filled. Now for 4f we would be having nothing but 10 more, rather for 4d, up to the level of 4d we would have 4s, 4p, 4d and 4f. In this 2 would be filled, 6 would be filled here. Then we would have here, how many will be filling? 10 will be filling here. Okay, and then we would be having nothing but, so for 4f another 14 electrons will be coming into the picture. Okay, so with up to 4d 18 electrons can fill, so 28 plus 18 will give me 46. So 4d, up to 4d all are filled, then only how many electron is remaining? 1 electron is remaining because the atomic number is 47. So after 4d what fills after 4d? 5. After 4d, rather if you look at the series, after 3p, rather after 4p 5d starts filling, and after 5s, rather after 4p 5s starts filling, and after 5s 4d starts filling. Okay, so we would be seeing the configuration of AGS at 1s2, 2s2, 2p6, 3s2, 3p6. Now after 3p 4s would be starting, 4s2, then after 4s 3d10 would be there, then after 3d10 4p 6, then 5s2, then 3d9. Okay, so we'd be actually seeing that about the full filled and half filled theory, but in the next lecture. But for now we can safely assume that as 3d only needs one electron to be fully filled, and fully filled would be more stable than partial filled, and hence one of the electrons would go here to complete the 3d orbital. As a result 5s1 and 3d10 would be getting formed. Not 3d10, this is 4d. Okay, this is 4d. Okay, so 5s1 then 4d10 would be getting filled. Okay, so just remember this series for filling of the electrons. So in case of AG, I'll again explain. 2 electrons are filled here, 2 electrons here, 6 electrons here, 2 electrons here, then 6 here, 2 here. How many electrons till now? 4, 6, 6, 18, 18 plus 2, 20 electrons are filled here, 27 are remaining. Okay, then again 10 will be filled here. How many are remaining? 17 are remaining. Then 6 are filled here. How many are remaining? 6 are filled here. How many are remaining? 11 are more remaining. 2 are filled here. How many are more remaining? 9 are more remaining. So now 9 will go into 4D. Now between 4D and 5S, we know that 4D is just 1 electron away from getting fully filled. Hence we'll take this more in the next lecture, but as it is just 1 electron away from getting fully filled, 5S will give its electron to 5s2 would give one of the electrons to 4d9 to become 5s1 itself, and 4d10 would be there. So just writing the electronic configuration here. So 1s2 here, 2s2 here, 2p6 here, 3s2 here, 3p6 here, 4s2 here, then 3d10 here, then 4p6 here, then 5s2 here, not 5s2, 5s2 converted into 5s1, and given 1 electron to 4d9 to become 4d10. So this would be the electronic configuration of AG47. So I hope you have a better understanding of writing electronic configurations by now. So with this we come to the end of this lecture. In the next lecture we'll be seeing partially filled and fully filled theory. Okay, so till then, good luck and goodbye.